Hello, my name is Luke Solomon, and this is our FRC Freshman Guide. What is FRC? FRC is short for First Robotics Competition, and it's where teams all over the world can come together and compete. This is a robot competition with much more to it than competing than you may think. It was created by Dean Kamen and Woody Flowers to encourage teenagers to join field of STEM. How is an FRC match played? In a match, there's a red and a blue team, which are called alliances. They have the corresponding team's colored bumpers. Each match, there will be 6 robots on the field, a 3 versus 3. A game split off into 3 sections. For last year, the match started off with the starting sound and had 15 seconds of autonomous period, where the robot is not driven, but everyone has pre-planned code telling the robot where to go. After the autonomous period of a match, then the driver will have full control of the robot for a minute and 45 seconds, which is called teleop period. Then, endgame, 30 seconds. It is still technically teleop, but this is the point in the game where there's usually an objective to score extra points. For example, making your robot climb a bar. Here is an example of a match being
3, 2, 1, go! All right, we are underway here in finals match number 2. Robo Wrangler stealing those Blue Alliance trench balls. 54-14 and Fusion Core sinking all kinds of power cells into the Blue Alliance's power port.
So you can see this timer up here. It's telling you what period you're in, and there's 1 second left of autonomous period, obviously not the match. And you can see all of the drivers are behind the line, and they are not driving at this point. And right after this time, you'll see them step forward.
Looks like as we start the driver control portion of finals match number 2, it's a 61-39 lead for the Red Alliance. Here comes 148 lining up close next to the Blue Alliance's driver station, sending a few balls up high for the Red Alliance. Red has already completed their first stage. They need 11 more to complete stage number 2. In their second quarterfinal match, they did complete all 3 stages. Let's see if they can do it again here in finals match number 2. Here comes Paradox, 54-14 on the far side of the field with some power cells trying to feed them back over to Fusion Core over on the blue scoring side of the field. Here comes 148, scoring another power cell. 118, scoring 3 for the Red Alliance. Red now needing 2 power cells to complete their second stage. 2 shots going way off. A couple shots going in by the Robo Wranglers. Now 111-62. And there goes the last power cell needed to complete the Red Alliance's second stage. 118 spinning that color wheel up on the near side of the field. Fusion Core.
So this is the game element of the year, which I probably should explain, but the objective was picking up these yellow power cells and scoring them here. And whichever team got the most points obviously wins, but each type of game element has different scoring. So this has its independent scoring. There's a color wheel right here which has its independent scoring, and then the climb. And those, I think, are the only 3 ways of scoring. Obviously there's fouls, but I think those are the only 3 ways of scoring at this.
Hunting for more power cells. Here comes 148, sending another volley of shots in. Red now needing 16 power cells with a minute left to complete their third.
You can also notice different strategies, but that's for a later episode. So if you notice this robot, they're playing defense over here. You can notice these 2 robots, which are cycling to get balls here and shooting, but that's for a later episode on strategy.
Third stage. 118 and 148 double teaming that Red Alliance power port. Red now needing 12 power cells to complete their third stage. 145-67, coming up on 45 seconds left to go. Paradox and Fusion Core trying to have a little robot makeout session here on the far side of the field. Paradox trying to expel some power cells from their robot and into Fusion Core. There goes 148 and 118 up high again. 2 power cells needed in order to complete their.
So if you heard that alarm, that means the 30 seconds of endgame have started, and this is the period, 30 seconds left in the period where teams can go up to climb. on this part.
Third stage, 148 trying to do it. 22 seconds left to go. There's 3 power cells in. 118 now trying to spin the color wheel to blue in order to complete their third stage for the second time in this event. There it goes. 3 complete stages for the Red Alliance. 8 seconds left. Can we get a double climb out of the Red Alliance? Up they go. 2 red robots up in balance. 198 to 71 is our score, not including climbs, as the buzzer rings on finals match number 2.
And here you go. At the end, you can see the score here. And typically during, I'll go more into this in the next slide, but you can see over here, that is typically where the ranking points go. But in this case, it's a finals match. So that's how many finals matches they won. And it's a best 2 out of 3. So they won the entire competition. So I'll go back to the PowerPoint.
Finals match number 2.
I clicked on it again. That's on me. So here is how you win an FRC match. Keep in mind, just a fair warning, it's different every year. So for last year, or in 2020, these were these 7-inch dodgeballs, and you had to shoot them into this goal over here. There's 3 different places where you could get points. So a low one, which is 1 point, the inner, which is the outer, which is 2, and the inner, which is 3. And obviously, you want to maximize points. So most teams wanted to aim for this goal. But obviously, there's strategy to it. So you just have to figure out what's the best strategy, and maybe not necessarily shooting in the upper always. Then the second way was by spinning the control panel, as you saw in the video, and the third was hanging on the scale during endgame. When do we get the game for each year? So it changes every year, as I mentioned. We call it kickoff day, and for this year, our past year was January 8th. And you have 6 weeks to brainstorm, design, and build a fully functioning robot that can complete the task of the game. There's a fun little video, but ultimately we have to read the entire rule book, which is 100 pages. And don't get intimidated by it. For some parts, we can skim, and some parts are repeated from year to year. So it's really just like parts of it are common sense. What happens once we get the game? So we'll go more in detail about this when it comes time for the actual tournament, and we'll have another video or another presentation. But we first want to figure out how we can maximize points, and then we make our wish preferred demand list based off of how we maximize points. We split off the game into sections and assign a group to each section. And this is very watered down. There's obviously going to be a lot more to it. So what do we do in robotics? We machine, CAD, fabricate, 3D print, CNC. There's much more to it. And then ultimately, we're here to learn and have fun. This is really ultimately a learning experience, and that's what we join robotics for. Second part too is going into more depth, machining and fabrication. That is making each specific part with the dimensions and drawings, then assembling all of it together. CAD is computer aided design, and you can design all on the computer, anything you want. And then 3D printing, this is plastic, you have a machine that can mold plastic into any shape based off a 3D model and the slicing. So now I'm going to go over all of the hand tools we use in robotics and the safety, how we use it, the cleanup, and the setup, sorry. So if there's a star up here, you can just notice it real quick, but these are the most important things and the things we use the most. Obviously, all of it's important, and I'm sure you're gonna learn it, but these are the most important. So this is a rivet gun, and these are called rivets, these metal things, and the setup is you put this short little side Inside here, you push the two handles together, and the use is mostly for assembling two parts. So if you have a sheet metal and a sheet metal and you need to combine them, you have a hole in the center and you put it through and you can combine them with rivets. Cleanup, pretty self-explanatory. Put everything back where you found it. Safety, obviously be wearing safety glasses. Um, and rivets do start flying, so obviously safety glasses. Deburr. There's no really setup except for getting your material you need to deburr, and the use is to soften sharp edges on metal. It can also be used for other materials, but majority of it is metal. Like you can't really have rough edges in inspection, so we definitely need to use the deburr to clean up edges. When you're done with it, just make sure you clean up your shavings and put the deburr back where you got it. Then the safety is don't point the sharp side towards yourself when you're cutting. I would always deburr away from yourself. And also, I recommend wearing safety glasses. Calipers, ensure the calipers are zeroed, and then what we use them for is measuring precise values under tenth of an inch. It has to be under 10 inches, but it does give you like, oh, sorry, thousandths of it. No, I think that's a thousandth of an inch. I'm not good with my scientific notation. And then clean up, just put it back. Safety, these things to mark it are sharp, so I just be careful with that. Center punch, there's no setup, you just need your materials. The use is to, after you get your measurement with your calipers, you poke the center punch so you can line up your drill when you're drilling. Clean up, just put it back where you found it, and then safety, just be mindful. It's a sharp edge, I guess. So. Clamp, make sure it's on a flat surface and sturdy. You don't want this to be loose or else the clamp is just going to be useless. Um, it's used to clamp parts to a stable surface for easier use. Cleanup, uh, I think it's mounted to our table, so you don't really have to put it back. Just make sure you leave it, like, take your part out of it when you're done. And then there's not really too much safety. Handsaw, how you set it up is you clamp down or secure the part being cut. You don't really set up the saw, but you set up the part you need to be cut. And you do not want to have it in your hand when you're sawing. You should always clamp it down. And its use is to make cuts, rough cuts. We typically like using the CNC for more precise things, so that's why it's for rough. And we'd use it for prototypes mainly. To clean up, just sweep vacuum the sawdust because wood shavings get everywhere. And then safety, safety glasses should be worn, and it's a sharp edge, so just be mindful. Keep in mind there's a star. We use this on a day-to-day basis, so it's one of the most important and useful tools we have in the room. And the setup is place the bit into the chuck. You place the bit here, like for example, it can be a drill bit or something else for a drill, I guess. There's a few different things you could use. Use drill holes and tightening screws. Clean up, return the drill and the drill bit back to their proper places, and also place the battery and the corresponding charger, obviously, so we have our batteries charging. And then, obviously, safety glasses when you're using these, and be careful. Impact driver, please do not get these two confused. It's the best way to get a robotics student mad. They have, I mean, I mistaken them before when I was a freshman once, but don't do it again. You get one freebie, and then you get flamed by the robotics team. But the biggest key identifier is the chuck right here, and you can tell this is um, much different right here. And that's one of the biggest key identifiers. It's basically same setup as a drill. The only difference from this and the drill is this is used for like when you need something faster and more powerful. That's why it's called an impact. So when you want to get through things, make holes faster, or I don't know, have like a stronger, more torquey um, way to cut, I would use this. And then safety glasses, put it back. They're not the same. Can't stress it enough. All right, so now we're gonna get into the machines within our robotics room. This is our CNC. This is probably the most dangerous thing in the robotics room. The setup, make sure when you're doing this for the first time, obviously you have a mentor with you, but you have to clamp the part to the wood and then attach the vacuum to here. You also need to slice, or not slice it, but you need to post-process it with the USB over here. And I think that, put your bit in. And then the use is to cut very complex or simple flat parts with great precision. Um, the cleanup, obviously clean up the shavings right here. You can see we purposely left that out for the photo. And safety, it's very dangerous. You should wear safety glasses and ear protection. 3D printers. So the setup is, these are very useful within our robotics, but the setup is not as complex as the CNC, but it is like um, very useful as is the CNC. Maybe not on the same level, but very useful. So the setup is heat bed, load the filament, which is this, and then clear the print bed from any other prints you have printed before previously. Use, it's for producing a plastic replica of any object modeled in 3D. Clean up, don't leave a mess around printers. Clean up scrap filament, take your part off the print. Just make it clean. Um, Safety, the plate and the nozzle. So the nozzle is right here, and then the plate is right here. They're very hot. They can get to extreme temperatures of like 300 Celsius, so just don't touch them. I don't know from experience that they're hot. The mill, this is our mill. The setup, clamp the part down right here. And it is basically a drill, but with super precise measurements. So the first thing you have to do is zero it on your part and find the end of the part and both edges of the part, and then it's basically like a grid on a map. So you can make it move this way and then move to your part and get it to the exact measurement you want. Clean up, sweep the shavings that are produced from it, and then safety, wear goggles, don't touch the spindle, and press the red stop button if anything, in the extreme case you need to. This is our lathe. We no longer have it, sadly, but it is still useful to know about. We previously used it for shaft collars, and you would make indents to put the circlip in. So you hold the piece in. But now we have clamping collars, which are, in my opinion, I like better because they're much easier and you don't have to CAD the indent. But the lathe is nonetheless very useful, and it's for spinning parts and making custom parts, but are like a different type of part that we don't really use as much anymore, though. But obviously, safety, red button, cleanup, put back where you found. No, it's just cleaning up the scraps. This should be mounted into wherever you're using it. Automatic sander. This is for, sorry, I'm jumping ahead. So the setup is plug in, turn on with the switch. Just make sure your hands are nowhere near it because it can shave down fingers. The use is to soften edges and cut pieces down. So if you cut something a little too long, you can shave it down a little bit. Or if it has a sharp edge, you can just put it on there and it'll clean it down. Clean up, there's going to be shavings, so clean the shavings up and then turn it off. Safety, it's very fast and can take your fingers, so just be mindful. Do not hold your part directly. Use some form of pliers or any way to make sure your hands are as far as away possible. This is our chop saw. I think there should be a star, but it's very important. The setup, there's a lock right here. You have to pull the pin out. It will release out. You have to plug it in and then clamp your piece down. Make sure it's tight. The use is for cutting parts, so 2x1. We can use it for wood and aluminum L. The cleanup, just clean your shavings and put it back where you found it. And then regarding safety, it's very sharp, so safety glasses and ear protection should be worn at all times when you're using it. This is the band saw. There should be a saw right here, but and it goes like this. But it was taken out for this photo, I guess, because they needed to replace it. The setup is line your part up, make sure it's marked already. It's used for cutting parts, small parts, because obviously the distance from here to here is not too big. Typically 1/8 inch aluminum stock. And then clean up, clean your shavings. Safety, very dangerous. Make sure your hands are away from it, just like the sander. And safety glasses should be worn. That's all. Thank you. Make sure to